Okay, so here's part 2. So these get a little tricky, but you just have to use some common sense. We're going to stick with this one, and we're going to solve for cosine. So we're going to add 3 to both sides. So we get 4 cosine squared theta equals 3. We're going to divide by 4, divide by 4, and we get cosine squared theta, or x, equals 3/4. We got to take the square root of that. Now listen, bada boom, bada bing, do the right thing. So we get cosine. Now I didn't square root this, I square rooted the cosine squared. So I get cosine of x equals plus or minus the square root of 3 over 2. Now remember, because it's cosine, this is my adjacent side, and this is my hypotenuse. Remember, square root of 3 is a trigger. We're going to have a 30, 60, 90, and the square root of 3 is the adjacent side. The adjacent's always my x-axis, and I got pluses and minuses. So that means if I go out the square root of 3 here, and my spinner's 2, this is 1, meaning this is 30, because that's always opposite my 1. But that can also happen here. 1, 2, negative square root of 3. It can also happen here. And it can also happen here. And so look at here. What do I got? I got the square root of 3 over 2 for cosine. Over here, negative square root of 3 over 2 for cosine. How about here? Negative square root of 3 over 2 for cosine. How about here? Positive square root of 3 over 2. Adjacent over hypotenuse. So all of my answers are 30, 150, 210, and that was 30, so that'd be 330. Now I'm not going to waste video time to convert those to radians. We should be getting better at that. Let's go on to this problem. So, how can I multiply two things together and get 0? Well, one of them has to be 0, so I have to investigate where does sine of x equal 0, and I have to investigate where does cosine of x equal 0. Not 0 degrees, 0. Well, by definition, sine is opposite over hypotenuse. How can I get 0 from this? My opposite side has to be 0. Remember in the quadrantals, we learned that that happens at 0 degrees and it happens at 180. So see my opposite sides right there? Those disappear. So there's 2 of my answers for this problem, 0 and 180. But how can cosine equal 0? Well, by definition, cosine is adjacent over hypotenuse. So that means my numerator has to be equal to 0 over something. So where does my adjacent side disappear? Well, remember, at 90 degrees, there's my little adjacent side. At 270, there's my little adjacent side. So my answer to this problem is 0, 90, 180, and 270. A couple more and we'll be done. Okay, kind of a long lesson, but let's tackle it. Again, like the previous example, something times something else equals 0, common sense. Tangent of x has to equal 0, or this, 2 cosine x plus 1 has to equal 0. Well, how can tangent equal 0? Well, what is tangent? Tangent by definition is opposite over adjacent. Remember, in order for that, a fraction to equal 0, the numerator has to be 0. And we just did this where the opposite side at 0 degrees, that's my opposite side, is 0, and then 180. So there's 2 of my answers because that's where the opposite side disappears. Now let's move on to this one. Subtract 1, subtract 1. 2 cosine x equals negative 1. Divide by 2, divide by 2. Cosine of x equals negative 1/2. Remember, my hypotenuse is never negative. So, how could my adjacent side be negative 1 and my hypotenuse 2? Well, I'm going to go out. Oh, by the way, all students take Calc. Where's cosine negative? Not here and not here. So where do I draw my x as negative 1? Right there. Which means this is my 2 and this is my square root of 3, meaning this is 60. And I can duplicate that drawing right here where this is 2, this is negative square root of 3, but this is also 60. So, if I spin my spinner 120 degrees, I get cosine is negative a half, because I got adjacent over hypotenuse. But if I spin my spinner 180 plus 60, which is 240, I also get that the negative 1 adjacent over hypotenuse is negative a half. So there's 2 of my answers and 2 more of my answers. This last one is quite tricky. So we use a little common sense, like I've been saying. How can you have a fraction equal 0? Well, the only way is that the numerator equals 0, because 0 divided by anything is 0. So I set the numerator equal to 0, subtract 1, and I say, hey, sine of some degree measure equals negative 1. How can this happen? Well, by definition, opposite over hypotenuse is sine. The hypotenuse is always positive 1. Opposite must be my negative 1. Where does that happen? Well, if we go back to this drawing, see my opposite side is 0 here, and it's 0 here. So it eliminates these as my answers. So I'm like, wait a minute. Okay, so if I go to 90, this is my opposite, which is positive 1. This is my hypotenuse, which is 1. We're like, wait a minute, that's 1 over 1. Is that our answer? No, because we need a negative. So 90 is not part of our answer. But if we flip the spinner all the way down to 270, which is 3 pi over 2, we'd go, okay, there's my opposite side, negative 1. There's my hypotenuse 1. I'm like, sweet, there's my answer. My answer must be 3 pi over 2. Why is this problem tricky? Because notice, it's divided by cosine of x. What's cosine of 3 pi over 2? Well, cosine of 3 pi over 2 would be adjacent, which is 0 over hypotenuse. So I'd go, oh, that'd be 0. Guess what? Can't have a 0 in the denominator, so the answer we found in the numerator does not work at all for the answer in the denominator, so this is a very tricky no solution. So you have to look at the big picture. All right, that was a grand finale. Good luck on your homework, you guys.